Hello, my dear students. Welcome to the electronics class. Today, in this session, you are going to study the part 2 of the unit 2. Okay, what is your unit 2? Name of the unit 2 is junction diode and its application. Another one point you remember that this is a title of the electronics paper, that is basic electronics and network analysis. So this is a title of the first SEM Maharani Science College for Women Autonomous Syllabus. Okay. So what is the basic electronics and network analysis means? In this second SEM paper, you are going to learn about the basics of electronics and about the network analysis. Okay. In this session, you are going to study the part 2 of the unit 2, that is junction diode and its applications. Okay. So what are the things you are going to study here? The construction, formation of depletion layer and IV characteristics of the PN junction diode you are going to study in this session. Okay. So in this session you are going to study about the construction, formation of depletion layer and the IV characteristics of the junction diode. Let us recap the last class, what we studied. In the last class, we studied about the PN junction diode, practical and ideal diode, symbol of the PN junction diode and practical diode, and what do you mean by biasing, types of biasing. Okay, let us come to the objectives of this session. Okay, that means what are the things you are going to study? The construction, formation and IV characteristics of the PN junction diode. After completing this, you should know the construction of the PN junction diode, how the formation of the depletion layer in the PN junction diode and the IV characteristics of the PN junction diode. Now let us move to the first point in this session, that is construction of the PN junction diode. Okay. So here constructions means what? We are not going to build any building here. Okay. Just we are constructing a PN junction diode. So in the last class everything we studied what is PN junction and all the thing here. And one thing we studied that P and N junction is either germanium or the silicon materials are there, semiconductor materials. Okay. And how to construct means actually here we have to take the any one of the germanium or the silicon material. Okay, any one material we should take, and next what we are going to do means half of that semiconductor material is doped with the P-type material and another half is doped with the N-type material. Okay, so then we are going to get the one PN junction and we are taking one terminal from the P-type, that is called the anode, another terminal from the N-type, that is called the cathode. Okay, here this is, I showed the symbol because this arrow mark shows the direction of the current when it is forward bias. Okay, let us revise the construction of the PN junction diode once again. It is a two-terminal device consisting of a PN junction formed either a germanium or the silicon crystal. Okay, and next a diode has a two terminal. One terminal is taken from the P-type layer and it is known as anode. The second terminal is taken from the N-type material and it is known as the cathode. Okay, how to construct this one? Let us take any one germanium or the silicon material. In that what happens, half of that semiconductor is doped with the P-type material and another half of the semiconductor is doped with the N-type material. Then we are going to get the PN junction diode. and the whatever the terminal taken from the p type is called the anode, and the terminal taken by the n type is called the cathode. Okay, now let us move to the formation of the depletion layer. Okay, and here what happens, this is a p type and the n type. When you are combining, you are going to get the one junction, that is called the pn junction, that I think already we studied in the last class. Okay, let us just see what is the pn junction diode. The diode is formed by joining both n type and p type semiconductor together. This device is a combination of p-type and n-type semiconductor material. Hence, it is known as p-n junction diode. Okay, one junction is formed between the p and n-type, then it is called a p-n junction. And I think all of you have remembered that in the p-type what happens, holes are the majority carriers. And in the n-type what happens, electrons are the majority carriers. In the p-type, electrons are the minority carriers, whereas in the n-type, holes are the minority carriers. Okay, and here what happens, all of we know that these holes are attracted by the electrons and the electrons are attracted by the holes. So here what happens, when the p-n junction is formed, holes are trying to cross this junction and move to the towards the n side. Why? Because these are the attracted by the electrons. And similarly, these electrons are trying to move from n to the p region. Okay, in this way what happens, some of the holes are tried and they are achieved the goal. That means they are come from p to the n side. In the same way, electrons from here to the here. Okay, here what happens, due to this, they are going to form a one layer. In this p type, they form a one electrons, and in the n layer, it forms the holes layer. And this layer is called what? Your depletion layer. Due to the attraction of the holes to the electrons and electrons to the holes, they form a one depletion layer. Okay, they form a one layer. Okay, and this is called what? The depletion layer. Now let us move to the IV characteristics of the PN junction diode. Okay, so here in this figure I showed the IV characteristics of both the semiconductors, that is germanium and the silicon. Okay, so here don't confuse with these two graphs. Okay, this actually only the x-axis and the y-axis I have drawn the one line, but these are the different. This is the characteristics for the germanium and this is the characteristics for the silicon. Okay, and let us study what is this knee voltage and all the things. Just let us study first the germanium. Okay, here what happens, IV characteristics is nothing but what? I is nothing but current, V is nothing but what? Voltage. And here what happens, just we are changing the voltage, and just we know when you are changing the voltage, what happens to the current when it is forward biased, that we are going to study. Actually, these IV characteristics of the PN junction are of the two types. One is the forward bias, another one is the reverse bias. So, when the circuit is connected in forward biased and when you are studying the characteristics, that is changing the voltage and you are seeing the current node, then it is called a forward bias of the IV characteristics. Okay, now the circuit is connected in forward bias, that all of you know how to connect the circuit in the forward bias. And in that what happens, just we are increasing the voltage from 0.1, 0.2, 0.3. What happens here, you see, from point 1 to point 3, there is a very small change in the current. That to here it is also 0, 1. 0 to 1 milliampere. Here the voltage is zero point 0.3. You are increasing from 0.1, 0.2, 0.3. 0.1 there is no current. For the 0.2 small current is there. For the 0.3 you are going to get the 1 milliampere nearly. But when it reaches the 0.3, what happens? When you are increasing from 0.3 to 0.4, there is a sudden rise in the current. Okay, that is a sudden rise in the current. That means what happens after zero point 0.3 volts, diode starts conducting. So when diode starts conducting, you are going to get the more current. Okay. So you see here, just within only 0.1 volts, you are able to get till 5 or more than 5 current. So this shows that during the forward bias, the diode starts conducting and it going to give you the output current. And another one point what we have to remember means this is about the germanium. When our diode is germanium, then our knee voltage is nothing but what your voltage. After this voltage, your diode starts conducting. That is 0.3 volts. The same thing if I have studied for the silicon. That means if your diode is made up of silicon semiconductor, then what is the knee voltage for the silicon? It is 0.7. That means here you see, if I have started from 0.5, from 0.1, 0.2, 0.3, you are not able to get any output voltage for the silicon voltage. When it reaches from 0.5, then you are going to get the small increase in the voltage. When it reaches 0.7, then there is a sudden rise in the output voltage. Output current. Okay, this is the knee voltage for the silicon. Okay, so what is the thing means, important thing in the forward bias means, whenever you are studying the IV characteristics, you have to remember that there are the two types of the characteristics are there, that is forward bias and the reverse bias. Okay, when the circuit is connected in forward bias, then you are using the increasing the voltage, note down the current value, then you are going to get the forward characteristics. Okay, and another one point you have to remember is when it is connected in reverse bias, and when we are studying the IV characteristics, then it is called the reverse characteristics. That we will study in the next slide. So before conclude this IV characteristics, let us revise once again. What are the things? What do you mean by IV characteristics? So here we are studying the voltage and current responses of the PN junction diode. So that is why it is called the IV characteristics. Usually what happens, voltage is taken across the X variable and current is taken across the Y variable. This is Y axis. Okay, this is the X axis and this is the Y axis. Okay, and here in the forward bias, what happens, germanium is having the knee voltage is 0.3 volts. That means till point D, the current is very small increase in the current. When it reaches 0.3, it starts conducting and it gives more current. In the same way, if our diode is silicon, it starts conducting after 0.7. So that is why we are calling that in the germanium we are having 0.3 as knee voltage and 0.7 as the knee voltage for the silicon. Okay, let us hope that all of you understood the concept of the forward bias. Now let us move to the reverse characteristics. I already told. Now the diode negative is connected to the positive of the diode and positive is connected to the negative of the battery. then it is called what the reverse characteristics. Okay, if you are unable to remember the circuit, please see my part 1 video. Okay, in that I have explained what do you mean by the forward bias and the reverse bias. But I already explained that in the reverse bias, the diode does not conduct and it is not going to give you any current. Okay, and here you see we are increasing the voltage at that too in negative, because negative of the diode is connected to the positive of the battery. That is -1 -2 you are increasing. Here what happens, for some small voltage, that is -1 -2, you are able to get little bit current, that too in microamps. I think you remembered micro is nothing but 10 to the power of -6. Okay, this is the reverse current. Okay, current is in microamps, whereas here voltage is in volts only. Hmm? And remember that in the reverse bias, you are going to get the current in microamps, whereas in the forward bias, you are going to get the current in milliamps. Milli is nothing but 10 to the power of -3, whereas micro is nothing but 10 to the power of -6. Please students make a one table for milliampere, microampere and next kilo, mega. Make a one table. That is for your reference. Okay, let us revise the reverse characteristics. All of we know that when the diode is reverse bias, then there is no flow of current. Okay, but even though what happens in the practical diode, we are able to get the, due to small increase in the voltage, there is a small increase in the current. But after some time, what happens, even though if you are increasing, you are going to get the small current, that to 0.1 microamps. Okay, this is about the reverse characteristics. Next, let us move to the ideal characteristics also. Ideal is nothing but what? That is full perfect diode. Okay, that is in the, just now we studied the forward bias characteristics and the reverse bias characteristics. In both the things, that is not a perfect diode. Okay, but in what is the ideal diode actually? If you have remembered, when it is forward biased, it full acts as an a conductor. When it is reverse biased, it acts as an a insulator. That means what? Here once again you see IV characteristics of the ideal diode. Once again here voltage is taken across x-axis, current is taken across the y-axis. But for the zero voltage in the forward bias, you are going to get the high current. In the reverse bias, what happens? You are going to get the, even though if you are increasing the voltage, you are not able to get any current here. Okay, increasing the voltage, zero current is there, because in the reverse bias, the diode acts as an insulator. Whereas in the forward bias, what happens? Your diode acts as a conductor. So the ideal is nothing but what? The perfect. Okay, let us hope all of you understood this IV characteristics of the PN junction diode. Students, please go through the video again and again. If you have any doubts, put the doubts in the comment box. Okay, so here after studying this, just you try to solve this MCQs. Okay, I think all of you understood this one. If you have any doubt, you can ask freely. Questions are welcome. Okay, thank you. Go through the video again because it is a somewhat new topic to you. Okay, and I have not used the Kannada because I am using a very simple English. So my intention is our students should go to the IAS and KAS level. Let us learn small English sentences also. Okay, but even though students, if you have any doubts and if you are not able to understand anything, means put in the comment that madam, I want in Kannada, then I am going to ready to explain in you Kannada students. Okay, thank you.